Hello friends, in this video we are going to discuss the previous year GATE question number 63. This question is from GATE 2007 examination. Let us read the question. A three-phase fully controlled thyristor bridge converter is used as line commutator inverter to feed 50 kilowatt power 420 volt DC to a three-phase 415 volt line 50 Hz AC mains. Consider DC link current to be constant. The RMS current of the thyristor is okay. So they have asked for the RMS value of the current flowing through the thyristor. So before moving towards the current flowing through the thyristor, let us find the load current first. Okay, because it is given that the DC link current, that is the load current, is constant. Okay, so here if you check the given data, P is equal to 50 kilowatt. So it is a 50 into 10 to the power 3 watt. It is given. What is the V0? It is equal to 420 volt. Next, what is the input voltage? Vi is equal to 415 volt. Okay, or we can consider it as a VL. Okay, line voltage it is. Okay, so it is a 415 volt. Next, as we know, P is equal to V0 into I0. Okay, but I0 is a constant, so let us consider it as a capital I0. Okay, so what is a P? It is a 50 into 10 to the power 3 is equal to V0 420 into I0. So from this can we write capital I0, that is a load current. Load current capital I0, yes, is equal to 50 into 10 to the power 3 divided by 420. Okay, so therefore I0 we can write I0 is equal to 119.047. Okay, 047 ampere. This is the current I0 we are having. Okay, now if you check, yes, in a 3-phase 6 pulse rectifier or in a inverter also, the any switch or any thyristor conducts for 120 degree. Okay, any thyristor conducts for 120 degree. Okay, so if you recall, yes, for 3-phase 6 pulse SCR also. Okay, then if you draw the waveform for IT1, it will be like from omega t 0. Okay, so for either for only for 120 degree it will be in the on state. Okay, so 0 to it is suppose 2 pi by 3, 2 pi by 3 to pi, and pi to till 2 pi will be having like this. Okay, and it is having a waveform like this. Okay, so this magnitude is I0 only. So now can we find the IT1 RMS? Yes, so we can write therefore IT1 RMS. They have asked for the RMS value. Okay, so we can write it as a 1 by 2 pi. Okay, 1 by 2 pi square root of mean of squared value. Okay, so we can write it as a 1 by 2 pi integration from 0 to 2 pi by 3. Yes, it is a I0 square into d omega t to the power 1 by 2, right? So this can be written as is equal to I0 upon root 2 pi into 2 pi by 3 to the power 1 by 2. Okay, so 2 pi will get cancelled. So if you check, it is a I0 by root 3, right? So it is a I0 upon root 3. Okay, so is equal to, what is I0? It is a 119.047 divided by root 3. Okay, so it is equal to 68.73 ampere. Okay, so this is about IT1 RMS value of thyristor current. Okay, 68.73. So if you check, the correct option is option C. This is about question number 63. In the next video we are going to discuss the question number 64. Thank you.